In this lecture, we are going to see about some practice question, some exercise question regarding a pipelining. Okay, so previous lecture we have already seen about this particular control unit. Okay, so when we are considering any pipelining, the control unit is divided into many function unit, right? Each function unit we are calling it a phase, and we also seen that when there is an uneven delays, then if you want to consider time period, then we will consider a maximum delay among this all the uneven delay as the time period for the pipelining, right? So here in this case 40 nanoseconds will be considered to the time period for the entire pipelining. Okay, so this is what we are seeing. So considering this example, I had framed one question. Okay, so this is the question. So in this question we can clearly see I had taken the example. Okay, this same example. Okay, using the same example I framed the questions. So here also there are 4-stage pipeline, and each stage is taking 9 nanoseconds. Here I am talking about this combinational circuit, right? 9 nanoseconds, 11 nanoseconds, 12 nanoseconds, 30 nanoseconds. So that is what I mentioned here also, right? And pipeline register are inserted between each stages. Yes, you can see each stages we have register inserted and introduce a delay of 1 nanosecond each. So we can see there are 1 nanosecond delay, right? Exactly same example I taken, right? Now assuming a constant clock rate. So we are assuming some constant clock rate here, means there is some time period here. At that time period only the data will move from one phase to another phase, right? That is the meaning of this particular line. Now consider the first example. So if all this scenario is there, then what would be let's try to solve the first question. So for the pipeline implementation, determine the clock cycle time. Clock cycle time means time taken for implementing an instruction using a pipeline. And here it is mentioned that time per instruction in a steady state. Okay, whenever you are talking about steady state, so you have to understand I am talking about one instruction. So this actual question means what is the time taken by a pipelining for executing one particular instruction. Okay, so how can you calculate? So remember the formula also. We will try to modify the formula which we have seen in previous lecture. Okay, so let's see the formula. Okay, so for first question, time taken by a pipelining for one instruction, right? For one instruction, right? So for one instruction, time taken will be how much? That is the question. Okay, to solve this question, just remember this note. In an unbalanced pipeline, the clock cycle time is determined by the maximum stage delay. Okay, so here what is the maximum stage delay? That is 40 nanoseconds, right? So that would be the time taken by the pipeline. Okay, that would be the time period for the pipeline. So for one instruction, you are considering here one instruction, right? What would be the maximum, what would be the time period? That would be maximum of time taken by stage S1, or time taken by stage S2, or time taken by stage S3, or time taken by stage S4, right? Now 1 into what is a maximum of, what is the time taken by stage S1? That is 11 nanoseconds, right? It is 11 nanoseconds, and here it is 12 nanoseconds, and here it is around 13, and then 14 nanoseconds, then 14 nanoseconds, right? Now whoever is the maximum, that become the stage delay. That would be the time period for the pipeline. So that is 14 nanoseconds, right? So answer is 14 nanoseconds, right? So the time taken for one instruction using a pipelining is 40 nanoseconds. Now consider the second question. What is the second question? For the non-pipeline implementation, determine the time required to complete one instruction. Okay. For this same scenario, what I am doing is I am not considering a pipelining. Okay. So we will come to this example. So when we are not considering pipelining, then you remove these registers. All these registers will be removed. Why? Because we are introduced register because of pipelining only. So when you are not using a pipelining, you just remove these registers. That's it. Then you just sum up all the delays of all the combination circuit. Then that is the total time taken for the pipelining. Okay. So I had written this note here. Without pipeline, each stage will take its own time, right? That is, S1 will take 9 nanoseconds, S2 will take 11, S3 12, S4 13. So since they happen sequentially, because without pipelining, every instruction will go through all the phases sequentially, right? So you just have to sum up all the delays. That's it. That is the answer. So time taken without pipeline for one instruction is equivalent to sum of all delays. That means time taken for S1 plus time taken for S2 plus time taken for S3 stage or time taken for S4 stage. Okay. Now you remember that I had already taken the register out, right? Then you don't calculate this 1 nanoseconds. Okay. Directly take 9, 11, 12 and 30 and sum them out, right? So that is what I am going to do. So I had already mentioned here. Now the stage will be whatever the delay of the stage is. That means S1 will take 9 nanoseconds, this will take 11 nanoseconds, this will take 12 nanoseconds, this will take 13 nanoseconds. Then what would be the total? Total will be, I think, 45 nanoseconds. So this will be the answer, right? Easy, right? Okay. Now the third question is calculate the total time required to process 100 instructions using a pipelining. Okay, so you have to calculate time taken for 100 instructions. Till now we were calculating for one instruction. Now what if there are 100 instructions? So how can you do this? We'll take third question, that time taken using a pipelining for 100 instructions, right? Now remember the formula. When you are using a pipelining, for first instruction will take 4 phases to come out, right? At the beginning, first instruction will take all the 4 stages to complete its execution at the beginning. Means it will take 4 clock cycles. So first instruction will take 4 phases at the beginning, right? And each phase has some time. I don't know what the time is. I will consider it as TC. You can see each stage will have some time, right? Each stage is accumulated some time, right? So I'm putting it as TC. Okay, I will calculate that part, don't worry. Now the remaining means 100 minus 1, 99 instruction. Okay, because of parallelism, it will take only one stage to come out. After remaining, first instruction will take 4 stages to come out, and after remaining 99 instruction will take 1 clock or 1 stage to come out, and that stage also takes some time, that is TC, right? Now your question is what this TC is, what would be the time taken. Now in terms of pipelining, we have already seen if there is unbalanced pipelining, okay, unbalanced or uneven delays, then clock time or time taken is the maximum stage delay. So among these delays, I will take the maximum one, and that would be my TC here. So 1 into 4 into 14 nanoseconds plus 99 into 1 plus 14 nanoseconds. Now if you calculate it, it will be around, I think, 56 nanoseconds and this will be around 1386 nanoseconds, and this will be total, I think 1442 nanoseconds. This would be the answer. Right, this is how you have to solve the question. Right, so back then I had not considered the time because there was a event delay, so you don't have to consider those things. But this is unbalanced pipelining, that's why we are taking the maximum delay. Right, so previously whatever formula we had seen, I just modified it little bit using this TC. Right, okay. Because the thing was that previously when we are talking about the stages, I was not talking about the delays, what would be the time taken for particular stage. Okay, we were just talking about that each instruction will go through this much stages. If there are 4 stages, then it will go through 4 stages. But how many, at each stage there would be some delay, right? That I was not considering back then when I was explaining the concept. So here in this concept we had also included a delays for each stages. That's why we had to include that particular delay also in the formula, that is TC. Right. So if you want to recollect it, what I had done is previously was I had taken time taken for pipelining. For one instruction I had gone through M phases, right, and that's it. Then for the remaining n-1 instruction, it is going for 1 phases, that it will take 1 clock cycle. That's it. This was the formula I had written. Right. Now in this formula I had not added the delays of the stages. So what I had done is I had added a delay also, that is TC. That's it. That is what I have done here. Right. Hope you understood. Now let's see the next question, that is calculate the total time, fourth one, total time required to process 100 instructions without pipelining. Okay, so you have to calculate 100 instruction time taken without a pipelining. Okay, this is easy. So we already knew that for one instruction what is the time taken, right? That is 40 nanoseconds. You just multiply by 100, that's it, that is the answer. So what I mean is, for example, time taken without pipeline for 100 instructions. See, there are 100 instructions, right? So for one instruction, what is the time taken? So time taken without pipeline for one instruction. What is the time taken? You just calculate it. And after that there are 100 instructions, you will multiply by 100, right? So what is the time taken for one instruction? Time taken for one instruction without pipelining we have already calculated, that is 45 nanoseconds, right? So 45 nanoseconds, and we have like this 100 instruction. So what would be the answer? 45 100, right? Nanoseconds. This would be the answer. Okay, so if you want it in terms of formula, then you can write like this. Okay, there are n instruction, okay, and time taken for one instruction would be, calculate, there are n instruction and time taken for each instruction, time taken for each instruction. Okay, so that would be the time taken for 100 instruction. If you want a formula, then you can consider this formula. Okay, so what is the formula? If there are n instruction, for n instruction, okay, what is time taken for each instruction, multiply by time taken by each instruction. Okay, this is how we solve the problem. Okay, I think you understood, right? If you want to understand this part also, see, I don't know whether you are getting, if you are getting it, then it's okay. Otherwise you can understand like this. See, for first instruction, okay, see, if you understood, then you can skip this video. Okay, otherwise you understand. For first instruction it will take 45 nanoseconds. For second it will take 45 nanoseconds. For third it will take 45 nanoseconds. Like this, so on for 100th instruction, again how many, what would be the time taken? So it would be 100 into 45, right? So that is what I done here, right? Okay, fine. So hope you understood. So these are the type of questions possible. Okay, so just be thorough and remember, if there are uneven delays, okay, if there are unbalanced pipelining, then you have to solve in this way only. Okay, always take a maximum stage delay. Okay, always take a maximum stage delay among all the stages in the pipelining when there is an unbalanced pipelining or uneven delays. If there is an even delay, then you don't have to worry. Okay, then you just have to calculate it as we used to calculate it.